Speedier than the outer layer of spacetime, it can stay aware of it, and it'll fundamentally tear. I'm scared by this. As of now, our night sky is changing quickly, and in a matter of a few years, if not sooner, it could become completely unrecognizable. Astronomers, in general, are sounding the alarm. Experts like Neil deGrasse Tyson have confirmed the inevitable impact of Polaris, and the story behind it is astonishing. Polaris, known as the North Star, has long been a constant in our night sky, serving as an essential reference point for stargazers, navigators, and astronomers. However, this could soon change, altering our night sky and astronomical evaluations. Let's dive into the significance of this threat and its implications for us all. Join us as we uncover the narrative of Polaris as it nears its end. For centuries, Polaris has guided sailors and stargazers alike, standing firm as a guiding light. Its steady presence in the night sky has been fundamental for navigation. However, this stability may soon be disrupted. In September 2023, a research paper presented by the prestigious Royal Astronomical Society cast doubt on the fate of this celestial beacon. Polaris is near the unstable brink of exploding, potentially disappearing from the night sky forever. Before we explore the consequences of this revelation, let's learn more about Polaris. Also called the North Star or Pole Star, Polaris is unique due to its proximity to the celestial North Pole. Positioned directly above Earth's North Pole, it appears nearly fixed in the northern sky and is located in the constellation Ursa Minor, or the Little Dipper. Polaris shines as a moderately bright yellow-white supergiant star, significantly larger and brighter than our Sun. It is not a single star but part of a complex triple star system, with Polaris A and Polaris B forming a binary pair, while Polaris B orbits them. The gravitational interactions between these stars shape their orbits and influence their behavior. Any disturbances in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the specific mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years from Earth, meaning the light we see from it today began its journey centuries ago. Therefore, if Polaris were to explode now, we wouldn't see it until over 300 years later. It's even possible that Polaris has already exploded, and we are yet to witness the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its steadfastness and fixed position made it a valuable guide for ancient sailors, helping them navigate seas and lands. Symbolically, Polaris represented loyalty and direction, remaining unwavering amidst the ever-changing night sky. For astronomers, Polaris served as a critical reference point, aiding in the study of celestial movements and variable stars. As a Cepheid variable star, its periodic variations in brightness have provided crucial insights into stellar properties and the nature of variable stars. This characteristic also played a vital role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, which has been a standard for the star, making it easier to anticipate its behavior. However, recently, Polaris has deviated from this standard behavior. This anomaly in its pulsation cycle has puzzled astronomers, prompting closer examination. Instead of following its usual pattern, Polaris has begun exhibiting unpredictable dimming patterns, raising concerns among scientists that the star may be nearing the end of its life. This aligns with behaviors typically observed in stars approaching the end of their life cycles. The ongoing expansion of Polaris's pulsation period, which was once stable, can be attributed to interactions within its star system. We have observed an annual increase in the pulsation length of 4.5 seconds, which may seem minor but holds significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these changes in its atmospheric conditions, directly affecting its pulsation patterns. Others worry that it is nearing the critical point of exploding. The similarities between Polaris's behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited complex anomalies in their brightness, raising concerns about a potential explosion. Stars in their twilight phase often show such peculiarities before reaching the end of their life cycles. NASA has expressed heightened concern about Betelgeuse. However, formal attention has not yet been directed toward Polaris. As a Cepheid star approaches the end of its life cycle, it undergoes several stages, including the main sequence, the red giant phase, and finally a supernova explosion. Considering Polaris's irregular pulsations, scientists predict it has entered the stages of helium depletion, typical of supergiant stars nearing their end. These anomalies in Polaris's behavior align with patterns common in stars in their twilight stages. However, convincing evidence of its imminent supernova remains uncertain. Astronomers are continuously monitoring these irregularities to understand Polaris's fate. If Polaris were to undergo a supernova explosion, it would likely be an epic event in our sky, potentially outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its appearance could dramatically alter our perception of prominent star constellations like the Big Dipper or Ursa Major, of which Polaris is a part. Rest assured, Earth would likely be completely safe whether or not Polaris were to explode, given its mass and distance from us. While a Polaris explosion may not be as visually stunning as Betelgeuse, it could still be visible to the naked eye for an extended period, dominating nearby stars. Astronomers and observatories would undoubtedly take note, sparking interest within the academic community and among stargazers. However, what about Polaris itself? What will be its fate after a potential supernova event? Let's clarify one thing. While supergiant stars typically end their lives with a supernova explosion, this is unlikely to be the case with Polaris. When a massive star undergoes a supernova, a massive explosion occurs within it, marking the final catastrophic stage in its life. This process involves a complete collapse of the core, triggering a violent shockwave that causes the star to explode. However, Polaris isn't massive enough to undergo such an explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition won't result in a supernova, but rather a peaceful end as it evolves into a quiet remnant. Little, very thick, heavenly leftover. A white, diminutive person is the extra center of a low or medium mass star that has depleted its atomic fuel. It's staggeringly thick, about the size of Earth yet as monstrous as the Sun. When this happens, we will never again see its leftovers from our planet as we see the star today. Differentiating the common impacts of Polaris blast with genuine cosmic explosion occasions offers important insights into the development of stars and their ultimate destinies. Contrasting our assumptions with genuine cosmic explosion events like SN 1987A and later occurrences, such as SN 2011 Fe or SN 2014 J, provides fundamental knowledge for understanding the potential outcomes of Polaris blast. For instance, SN 1054 prompted the formation of the Crab Nebula, a cloud that continues to expand and release radiation across various frequencies, offering cosmologists a rich field for study. Additionally, SN 1987A, observed in the Large Magellanic Cloud, provided insights into the patterns of nucleosynthesis and the elements of cosmic explosion leftovers, including phenomena such as the formation of nebulae, the release of massive beams, and changes in glow, which can reveal insight into Polaris' exceptional characteristics. The formation of nebulae, like the Crab Nebula, results from the release of material during the cosmic explosion blast, which then interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of heavenly birth and death. Also, the release of massive beams and high-energy particles rapidly pushed by cosmic explosion shockwaves has implications for astrophysical processes and vast radiation conditions. To make a definitive comparison, researchers are evaluating differences in the large-scale composition and velocity of ejected materials between Polaris' expected blast and other observed events. This includes studying the light curves, spectra, and remnants of these events, and extrapolating similar characteristics for Polaris' potential blast, assessing whether it may lead to the formation of nebulae or significant heavenly dispersions. This improves our understanding of its potential consequences. Another significant area of study involves examining the pulsational variability of stars approaching their end stages. Comparing Polaris against other cosmic explosion forebears, this overall analysis can help estimate similarities or deviations and provide insights into the explosive mechanisms. Pulsational variation in stars nearing the end of their lives may indicate internal hazards or impending catastrophic events, offering clues to the developmental processes leading to cosmic explosion blasts. Despite careful observations and extensive research, space experts remain puzzled by the anomalies found in Polaris conduct. Unraveling the unique circumstances driving these inconsistencies holds the key to advancing our understanding of heavenly evolution. Understanding the dynamics responsible for Polaris' irregular throbs requires interdisciplinary collaboration as well as the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a significant reference point in the night sky raises key questions for galactic undertakings. Ground-based telescopes and divine measurements would require recalibration, affecting the accuracy of cosmic estimations. The absence of Polaris could also impact navigation systems and cultural practices based on heavenly landmarks, highlighting the significance of this divine event. The mysterious behavior displayed by Polaris underscores the need for deeper investigations and dedicated research efforts. Cosmologists must grapple with the complexities surrounding its erratic throbs and provide meaningful responses, recognizing the importance of advancing our understanding of divine complexities. The answer to Polaris' fate remains uncertain, and only time will reveal its true nature. Still, the quest for knowledge and understanding, despite immense uncertainty, is a testament to humanity's enduring curiosity in unraveling the mysteries of the universe. The implications of Polaris' potential downfall stretch beyond simple galactic interest. They touch on the very fabric of how humanity perceives its place in the universe. Since the earliest days of recorded history, constellations have served as markers of time and navigation, guiding pioneers across uncharted waters and lands. The loss of Polaris wouldn't just disrupt traditional navigation methods but could also have sweeping implications for cultural myths and symbolism tied to the North Star. In various cultures, Polaris has been central to folklore and spirituality. For example, Native American tribes often viewed Polaris as a guiding light in their stories, symbolizing hope and perseverance. Similarly, the ancient Egyptians used the North Star in their architectural designs, aligning pyramids to its position. The disappearance of such a prominent star could alter cultural narratives and the fabric of human experience related to navigation and direction. Moreover, the academic community would face significant challenges if Polaris were to disappear. Cosmic measurements and observations heavily rely on established reference points. Polaris' role as a constant guide has facilitated the calibration of instruments and models used to study distant worlds, star formations, and even the expansion of the universe. The sudden absence of Polaris would require recalibrating many of these systems, potentially leading to discrepancies in measurements and interpretations of divine phenomena. As astronomers focus on observing Polaris more closely, new observational advancements are being developed. Progress in spectroscopy and photometry enables scientists to examine light emitted by stars in unprecedented detail. These instruments help identify minute changes in brightness, which are essential for understanding the mechanisms driving heavenly behavior. As researchers gather more data, they aim to refine their models of heavenly evolution, particularly concerning stars in the later stages of their life cycles. The study of other similar stars, such as Cepheids and red giants, offers insights that could prove valuable. For instance, astronomers are observing factors like the period-luminosity relationship, which helps in measuring distances across the universe. By comparing these stars' behaviors with those of Polaris, researchers hope to gain a clearer understanding of heavenly dynamics and evolution, further enhancing their interest in the design of our universe. In addition, as the search for exoplanets intensifies, the study of Polaris and its companions becomes increasingly critical. Understanding the characteristics of stars and triple systems can provide significant insights into the formation and habitability of planets orbiting them. Astronomers are deeply interested in how such stars affect their surroundings, potentially influencing the conditions under which planets form and evolve.